All right, so I want to go over a couple of the probability formulas that you need to know. So I'm going to go through the second one first, just if you can bear with me real quick. So this formula right here, this symbol means given. So the probability of A given B is always equal to the probability of both A and B, right? The probability of both of them happening divided by whatever is second. So the probability of B. That's the first formula. Okay. We'll go through a couple of problems in this in a second. Um, the other formula that you need to know for probability is the probability of A or B is equal to the whatever the probability of A is plus the probability of B minus the probability of A and B. Okay. So whenever you see a question like that, think of the Venn diagram. Okay. So if I tell you math and biology, cool. So if I tell you all together there in math, there are 25 students taking math. There in biology, there are 20 students taking biology. And if I tell you for math and biology that there are 10 students, okay, hear me out. So if I said how many students are, what's the probability of students are taking math or biology, okay, which is this right here. Or is the symbol for or is right there. Cool. So if I said to you, what is that? I would take the probability of, right, the first one. So 25 students are here altogether. So I'm going to do 25 plus probability of B, right? My biology is 20. So there are 20 students that are in bio. Okay, cool. But then I have to subtract the students. You see how these students right here are in both? They're double counted. So I have to subtract how many are in both. So there are 10 in both. So 25 plus 20, right? That's 45. Minus 10 is 35. So there are 35 students who are in math or biology. Okay, that's our answer. That's how you use this formula right here. Okay, cool. Testing for independence. How do we do that? We say the probability for A, right? No matter what B is, it doesn't matter. The probability for test for independence is probability of A is equal to the probability of A given B, right? Basically, it's saying that the B is irrelevant. No matter what happens, A is going to happen in spite of it, okay? Another formula that you can use is the probability of A and B is the probability of A times the probability of B, okay? So those are the two formulas to test for independence. So I'm going to just pause and we're going to do a couple of problems real quick. All right, so I want to do a problem for given first, if that's okay. So this question here has the word given in it. It says the probability that a fan prefers pizza. So the probability that a fan prefers pizza, given, that's a symbol for given, that the fan prefers football. Okay, so pizza, given, football. So let's go back and write down the formula. Probability of pizza and football divided by whatever second. So the second one is football. Cool. So I look for pizza. Here's pizza. And football. Here's football. Okay. That was horribly drawn, but you get the point, right? Here's football. Cool. So pizza and football, where do they meet? Right here. 20. So 20 goes on the top. Cool. And then I said it says probability of football goes on the bottom, right? So football, I go across from football, which is this whole right here, this whole row. So 14 plus 20 plus 6. 14 plus 20 plus 6, right? 20 plus 14 plus 6 is 40. So 40 goes on the bottom, and 20 divided by 40 is the same thing as 1/2. So there's my answer. Okay. If I did another one, uh, it says, what is the probability that a randomly selected person is male given the person is left handed? So it's prefers probability of male given the person is left-handed. Cool. So we do both on top, probability of male and left-handed over whatever second. So left-handed is second. Cool. So the probability of male and left-handed, here's males, here's left-handed. So both is 13. So 13 goes on the top over the total number of L, which is left-handed. So I'm going to take the left-handed people and add them up. So 13 plus 11 is 24. So 13 over 24 is my answer. Okay. Are we getting the hint how to do this? All right. For independence, I'm going to do question number 7. So are the students, you can take a look at the question. Are the events student is a male and student prefers reality series independent of each other? Cool. So we want to see if the probability of a student being a male, right, versus if a student prefers reality series, right? So probability of male given reality series, right? So reality series is here, but they're still a male. So we want to see if they are independent of each other. Okay. So basically we want to see if they're the same, if these are the same, or if they're different. So if they are different, they are dependent. If they are the same, they are independent. Okay. Different, dependent, same, independent is the way I remember it. Cool. So, what is the probability of being a male? Okay, so how many males do we have here? So, males, the total number of males is 230. So, I have 230 males out of the total population, which is 490. Okay, so that is the probability of being a male. Okay, in this scenario, Central High School. Cool. Now we want to see the probability of males given that they watch reality series or they're into reality series. Okay. So that is males and reality series is 70. So this is going to be 70 out of, right? And we want to see males given reality series, the R is on the bottom. So how many reality series people are there? There's a total of 180 reality people, reality series preferences. Okay. So what we just did is the formula that we did before with given, we just applied it right here, right? Males and reality is 70, right? We wanted to see where they meet. So let me see if I could do that again better. Males and reality series, right? So that number is 70. That went on the top. Cool. And whatever's on the bottom, the reality series goes on the bottom. So the total reality series is 180. They already did the math for us. How kind. That went on the bottom. Okay. So we want to see if these are the same. If they're the same, they're going to be independent. If they are different, they're going to be dependent. So my handy dandy calculator comes in. I'm going to clear what's there. So I'm going to just do 230 divided by 490 because I want to change that to a decimal. And I want to see if that's the same or different as 70 divided by 180. Cool. So those are different, right? Which means that they are dependent. They are not independent. So let's answer our question. So they are not independent. So the answer is no. And it says justify your answer. Me doing this work, right? Me doing this work is justification. They are not the same. Okay. So I've answered my question. So if they say, are they independent? You have to say yes or no. So in this case, the answer is no. And my justification is my work, right? 230 over 490 is not the same as 70 over 180. Different, dependent, same, independent. All right. Cool. We're going to go ahead and try number 6 as well. This might be a little bit crazier because it says for this group of students, do these data suggest that gender and preferred music styles are independent. So gender. So we just need to pick a gender. So I'm going to go ahead and pick females because I'm a female. Okay. So probability of females. And we have to see if they are, just like we started out before, if they are independent of preferred music styles. So the probability of female given something else, right? So it says techno. So the probability of techno, the probability of female given rap, and the probability of female given country. So this might have a couple of different things that we have to test. Same thing though, okay? So the probability of female. So how many females are there? So we want to take these females thing, we want to add this up, right? Total number of females. 54 plus 25 plus 27. So the probability of females, how many females are there? There are 106 if we add those up. Okay? Then we have to take the total number of people altogether. So the poll is 200. So the number of females is going to be 106 out of 200. Cool. Now we have to figure out each of the other ones, right? So female given that they prefer techno. So that's 54 out of the total techno. Total techno is going to be 90. Okay. I want to do the same thing here. Females preferring rap. So females and rap is 25 out of the total rap. Right here, if I add this up, I get 65. Cool. And the last one is females and country is 27 out of straight country. If I add this up, is going to be 45. Okay. So I want to see if they're the same. So this one, I plugged this into my calculator earlier. This is 0.6. The probability of females given rap is 0.39. Okay. And the probability of females given techno is 0.6. 0.6. Okay. So 106 divided by 200, this number right here is going to equal 0.53. And just like we said down here, right? If they are different, which they are dependent. They are not independent. Okay. Um, if they are the same, none of these are the same, right? 50.53, these are all different. Okay. So for this group of students, do this data suggest that gender and preferred music styles are independent? The answer is no. 90% of the time, it's going to be no. I'm not sure what they're going to do on Monday, but check your answers anyway. If they're different, they're dependent, they're not independent. So, are they independent of each other? The answer is no. Okay, they do not appear to be independent. And justification is right. All this work, these are not the same. Okay, all right. I think you get the point. You can go ahead and pause and do question number 8 on your own. And very quickly, right? Unstop the video, and we'll go ahead and do this together. So the probability of Felipe wins, right, and long-term practice. So probability of Felipe given long-term practice, we want to see if that's the same or different than the probability of Felipe winning. Cool. So probability of Felipe given long-term practice, right? Felipe given long-term practice, that number is going to be 12 out of 27. Okay. And the probability of Felipe winning is going to be, right? Felipe wins 10 plus 12 is 22. Out of the total is 45. If you add all those numbers up, all four of them, okay, you get 45. And these are not the same. You are not the father. Okay. So since they are not the same, the events are no, they're are not independent, and we've just justified our answer. Okay, this is all our work. Great job. Hopefully that explains it.